Okay, have you ever stopped, really looked at the screen right in front of you, and just wondered, are we interacting with computers completely wrong? I mean, every single day we rely on these heavy, bloated graphical interfaces. We tap, we swipe, we point, and we click. And, it feels totally natural, mostly because it's exactly what we've been conditioned to do for decades. But what if this pretty visual illusion is actually a massive dead end? What if relying on all these shiny abstractions is literally holding us back, severely limiting our potential to communicate with machines at the actual speed of thought? There is this incredibly visceral quote from free software legal scholar Eben Moglen that just absolutely hits the nail on the head here. He says, "We get the chimpanzee hitting buttons, but we chat with each other. It isn't as good." Seriously, just think about that for a second. We human beings, we're built for deep, beautifully nuanced language. We write, we debate, we chat. But when we're forced to interact with our machines through these pre-drawn graphical buttons, we're trading that profound expressive power for the absolute simplicity of pulling a colorful lever. We are essentially reducing ourselves to animals, just pushing buttons for a quick dopamine reward. Crazy, right? So today, in this explainer, we are going to look right past that illusion. We're exploring a massive paradigm shift away from that passive button-pushing experience. We're going to uncover this incredible concept called the Agentic Typewriter, and in the process, expose exactly why the graphical interface is, frankly, a technological dead end. To guide us through this dense architectural and philosophical journey, here is our roadmap for today. First, the GUI dead end. Second, mind versus machine. Third, the semiotic bridge. Fourth, the Agentic Typewriter. And finally, fifth, the sovereign pilot. Okay, let's dive right into this. Section 1, the GUI dead end. We really need to rethink this widely accepted norm that GUIs are somehow the absolute pinnacle of computing. Because fundamentally, they aren't built for precise automation at all. They are built for human eyes. Critics actually often call the GUI a caveman interface, since it's based purely on, well, point and grunt interaction. It's this fragile, bloated layer of visual translation that requires massive computational power just to render visual illusions, stuff like drop shadows, rounded corners, and smooth animations. And when we accept this setup, it dictates the terms to us. It effectively reduces us, the human pilots, to passive digital tenants who are just quietly renting space from some invisible tech monarch. Think about it. If a software developer didn't draw a button for a specific action, well, you simply can't do it. No button, no action. The contrast becomes incredibly stark when you actually try to automate tasks. When an AI tries to interact with a GUI, it's forced to use these incredibly fragile, hacky workarounds, like screen scraping. The AI takes this messy, pixelated picture of your screen and literally guesses what to click based on shapes. If a website changes a single pixel, boom, the automation instantly breaks. It's a complete house of cards. But compare that to the command line interface, or CLI. It is streamlined, unmediated reality. It bypasses all of that heavy visual bloat, generating a 100% exact lossless text log. There is zero guessing on a pixelated screen here, just pure, undeniable digital truth. Section 2, mind versus machine. To really understand exactly why the GUI fails us so badly, we have to look past the software and descend right down to the bare metal. We are dealing with a terrifying modality gap between two totally alien worlds. On one side, you have OS alpha, that's your brain. It is warm, messy, highly associative, totally continuous, and beautifully fueled by your lived experience. Then, on the exact opposite side, we have the hardware's arithmetic logic unit, the ALU. It is completely cold, rigid, and driven entirely by exact electrical voltages. The machine is utterly blind to our human semantic meaning. So the crucial point to take away here is that hardware demands absolute determinism. Because of this massive physical divide we just talked about, the microchip requires discrete, unapologetic exactness to execute anything at all. It just cannot process the fuzzy associative intent of a human without a totally exact translation. When you introduce the probabilistic guessing of AI on top of a bloated GUI, you are entirely losing that deterministic safety. The machine absolutely needs to operate with zero runtime variance, no guesswork allowed. Section 3, the semiotic bridge. Now, you might be wondering, If human thought is so fluid and silicon is just so rigidly mechanical, how on earth do we connect them without a catastrophic mistranslation? Well, we cross that massive gap using the undeniable solution, the semiotic bridge. Strictly formatted text, things like JSON or Python, acts as this universal translation layer. Pure, explicit text is, quite literally, the only medium capable of perfectly mapping your nonlinear, fluid imagination straight onto the unyielding physical grid of a processor's logic gates. Text isn't just for us humans texting each other anymore. It is the exact deterministic operational literature of machines. Let's walk through how this flawless translation workflow operates. It's a simple three-step process. First, human intent initiates the strategy up in that messy associative realm of OS alpha. Second, we use structured text to translate that intent. The text safely squeezes all that boundless imagination into a rigid, structured template. And third, the hardware executes the exact physical logic required. This step-by-step workflow proves that human thought literally must be funneled through a rigid textual bridge just to command the machine. There's a profound, honestly kind of hilarious metaphor from the sources that perfectly captures this whole reality. We are, quite literally, tricking rocks into thinking using lightning and text. I absolutely love that. We take silicon substrates, rocks, pump electrical currents through them, lightning, and use explicit language to force them to execute our wildest imaginations. There is no magic ghost in the machine here, folks. It's just physical hardware, electrical current, and the exact deterministic script of text. Section 4, the Agentic Typewriter. This is where we shift to the ultimate universal interface. The Agentic Typewriter totally strips away all that visual guesswork we've been dissecting. By using a CLI like the Gemini or Metadata CLI, this system acts as a direct translator of human thought right into machine computation. There are no clunky drop-down menus, no fragile pixels to break. It natively bridges your human imagination into physical silicon using pure, explicit keystrokes. You simply type out your mandate at the speed of thought, and it executes. It really is that direct. Now, what's absolutely crucial to understand here are the actual mechanics making this so incredibly powerful. Think about how fragile your web browser is. If your internet flickers for even a millisecond or an API drops, the page refreshes, and poof, hours of complex AI context are instantly just gone. The Agentic Typewriter fixes this entirely by utilizing Unbreakable pseudo-terminal, or PTY, channels. It's a completely isolated, secure, text-only pipeline going straight into the machine's core. And because it operates purely on a deterministic monospace grid, the AI agent doesn't need to visually decode some messy interface. It just reads perfectly lossless text. This guarantees zero data loss and completely defeats what the sources call the probabilistic miasma. You know, that foggy, unreliable guesswork and hallucination you constantly get with modern AI models. Section 5, the sovereign pilot. Once you strip away the GUI and establish this unbreakable text pipeline, your role as the user completely transforms. The architectural documentation illustrates this dynamically. The human pilot applies the intent, but the agent cell executes the sweat. In this new era, the machine acts as a deterministic scripter, doing all the heavy computational lifting. But you remain the sovereign pilot. Achieving this requires what the sources term protorsion and the sweat of the brow. See, because continuous AI models are fundamentally associative, they guess, they make assumptions. So, to protect your vision, you must physically step in. You have to manually edit and physically prune the text to bend the rigid machine toward your specific intent. It is your active, human rhetorical control that maintains the safety and prevents catastrophic errors. So as these incredibly powerful agentic tools integrate into absolutely every aspect of our lives, you are faced with a massive choice. Will you succumb to the heavy visual illusions of the GUI dead end, passively renting space and remaining a chimpanzee just pulling levers hoping for a reward? Or will you embrace the semiotic bridge, grasp the sword arm of the CLI, and ride as the sovereign pilot of your own digital future? Remember, the machine is just a deterministic brush waiting for your explicit instructions. Your role is no longer just generating content. It's architecting actual meaning. The choice is entirely yours. Thanks so much for joining me on this explainer. Keep questioning the architecture around you and, as always, look past the screen.